All right, so let's look at, you're welcome once again. Let's look at water dispersible suppository basis, okay? From the name water dispersible, it means that it doesn't dissolve, right? They don't dissolve. Hope you know.
Okay, what
Dispersible doesn't meet this dissolution.
like the dispersing water
If something disperses, it's not the same thing with what?
dissolve.
Dissolving. Is that clear?
Yes.
Dispersing. If something disperses, it can form a dispersion. Something like suspension. But if it dissolves, it forms a what? Solution. Is that clear? That the general meaning. I'm just telling you the general meaning of what? The general meaning of what? Disperse. When you say that something is dispersible. Is that clear? All right. So now let's look at water dispersible suppository basis. Okay. So this water dispersible basis, these ones can be used to formulate both water soluble and oil what soluble drugs. Please note that point. Water dispersible basis can be used to do what? Formulate what? Both what? Water soluble and oil soluble what? Drugs. Example, twin and sperm. Now, most of the non-ionic surface, non-ionic surface active agents, most of them are used chemically as what? Sorry. Now, let's go straight to the point. Leave long stories. The main point I want you to note here is that what is it called? That the basis used for that this water, the dispersible basis can be used to formulate both what? Water soluble and what? Oil soluble what? So that's the most important thing I want you to note here. Is that clear?
Yes, sir.
Good. Now, what are advantages of this? What are advantages of this? What is it called? This water the dispersible basis. What are the advantages? They can be stable when stored at elevated temperature. So they can withstand high what? Temperature. They are compatible with many drugs. That's why I say that they can be used for what? Water soluble drugs and even what? Oil soluble drugs. They do not support microbial growth. They are non-toxic and they are non-sensitive. So, water dispersible suppository basis, you see things like cellulose derivatives, the soluble ones, things like methyl cellulose and sodium carboxymethyl cellulose. Please, I'm giving examples now. Methyl what? Cellulose. They are water soluble cellulose derivatives. We have methyl cellulose, then we have sodium carboxymethyl what? Cellulose. Sodium CMC. Is that clear? Then if
Carboxyl. Carboxyl.
methyl
Okay, carboxyl.
cellulose, sodium CMC, carboxymethyl what? Cellulose. Is that clear?
Yes, sir.
They are examples of what? Water dispersible suppository base. Is that clear?
Yes, sir.
Now, on other these non-ionic surfactants are also there. Is that clear?
Yes, sir.
I have given you an example of twin and span, right?
Yes, sir.
Good. Now, I would want us to talk more on this. This is the ones we can take on this water dispersible what basis. Now, let's go to another ingredient. We are not going to adjuvants now. We are done with basis. These bases have taken us time. Is that clear?
Yes, sir.
So we are done with what? Basis. We are done with what? Basis. Any question on basis?
No, sir.
No question on basis, okay? So let's look at other what is called adjuvants. Okay. So let's start with antioxidants. 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 So antioxidants, from the name, they prevent what? Good, thank you. So if antioxidants protect the drug and bases from getting degraded due to what? Oxidation. They protect the drug and the bases at the same time. Because if the base get degraded, the drug will waste now, true of us.
True.
So, and if the drug itself get degraded, it not act. So two of them, bases and the drug, are being protected by what? Antioxidants. So they are commonly used in all types of suppositories. If you know that point, they are commonly used in all types of suppositories. Examples of antioxidants used are as follows: ethyl or propyl gallate, ascorbic acid, butylated hydroxyanisole (BHA), butylated hydroxytoluene (BHT), hydroquinone, and tocophenol. These are examples of what? Antioxidant used. And the another adjuvant is what? Emulsifying what? Agents. From the name emulsifying, emulsion brings what? Two immiscible to come together, right? So emulsifying agents, this emulsifying agent, what they do is that they increase the water absorbing capacity of fatty bases. Please note that point. We discussed this. I don't know whether you were in a class. Emulsifying agent, they increase the what? Water absorbing capacity of what? Fatty base. You know, under normal circumstances, not to concern oil and water now. Fatty bases are oily. So what the only thing can make them to be able to the fatty base to take in water, or water soluble whatever component is to use what? Emulsifier. Is that clear?
Yes, sir.
So examples of these are polysorbate, 261, wool alcohol, wool fats. These are examples of what? Emulsifying agent that you can use. And we also have hardening agents. For them, hardening makes it harder, right?
Yes, sir.
So hardening agents are involved in formulation where the melting point of the basis is decreased by the drug. Remember, if we're not in the class, when we discussed theobromine oil, its effect when you add chlorohydrates and phenols, it will do what? Soften it. Now, you can add hardening agent to make it because of the drug you added it. If you add some drugs in some bases, those drugs will make the base to be soft, and if it's too soft, it's a problem. Tell me how we are going to administer a very soft suppository to waste now. True of us? At least it should be hard enough to be able to penetrate the what? Anus. It's not true?
Yes.
Or the vagina. So the hardening agents are used when you are formulating when you are preparing suppository using suppository base whose melting point is decreased by some drugs. Is that clear?
Yes, sir.
So now these agents are used to bring the melting point back to what? Normal. They are used to bring the melting point back to what? Normal. Examples are beeswax, and high molecular weight macrogos. So high molecular weight macrogos can also act as what? Hardening what? Agent. Is that clear?
Yes, sir.
Then the next what is it called? The next adjuvant is the what? Preservatives. From the name, they preserve, right?
Yes, sir.
So this preservative, what do? They are used to prevent microbial what? Growth. Mainly, you see that one mainly in what? Suppository that contains water soluble what? Bases. Because water is a very good environment for what? Microbial growth. True of us?
True.
So examples of preservative are chlorocresol, methylparaben, propylparaben. These are examples of what? Preservative that we use. Then the next group of adjuvant is a thickening agent. So these agents are used to increase the viscosity. So anytime we hear thickening, you're talking about what? Viscosity, right? They are used to increase the what? The viscosity of molten bases. They are used to increase the what? The viscosity of molten bases. So when this is improved or is increased, it helps to prevent sedimentation of suspended solid bases. Suspended solid in the base. You know that if it's not thick, if the thing is not thick, this solid that is suspended in the base will sediment. Is that clear?
Yes, sir.
So we need thickening agent to make it. If this thing is thick now, let's assume this liquid here is very thick. If you add solid now, the solid will hang. True of us? It not. But if it's not thick, add it to just go and settle and sediment here. Is that clear? Good. So that's what thickening agents do. Examples: we have aluminium monostearate, we have colloidal silica, we have magnesium stearate, we have stearyl alcohol. These are examples of thickening what? Agents. So the next group is what? Plasticizers. The next group are what? Plasticizers. I've talked about the plasticizer. They help to increase the what? Flexibility or fluidity, okay? So plasticizers are agents that are used to improve the flexibility of the what? Suppository. Is that clear?
Yes.
So use flexibility or fluidity. So a good each of these one has if it has a very good fluid, if it is fluid and good, if the fluidity is okay, it will not be brittle. True of us?
True.
Do you know why this thing is not brittle? It has fluidity. There's moisture content in this plastic. But if you expose it to hygroscopic substance now, it will take in all the. It will be, if you bring it up, it will break. It will break. You see that if you press it in, it comes out. There is fluidity. The plasters are here. The fluidity. It has fluidity, and at the same time, that means it's flexible, right?
Yes, sir.
Good. Examples of plasticizers are castor oils, glycerin, glycerol, 2-in-80, 2-in-85. These are examples of what? Plasticizers. So with this now, we'll come to the end of our discussion on the ingredient used in what? Preparing what? Suppository. Our next topic will be on the formulation and production of what? Suppositories. That will be our next topic. Any questions so far? No question. All right. Thank you very much for your attention. God bless you.